Okay, 143 degrees 17 minutes 20 seconds plus 216 degrees 42 minutes and 33 seconds, it gives us 359 degrees 59 minutes 53 seconds. So what we do here, you're gonna say 360 minus 359 59 and 53, so that we can try correct our measured angle, so we get our reduced angle. So you're gonna divide the answer that you got, which is this, you divide it by 2, it's gonna be 0 0 3.5. So after getting that, in order for you to get your reduced angle, you're gonna say this answer that you got, which is 0 degrees 0 minute and 35 seconds, you add it to 143 degrees 17 20. So you're gonna say this plus 143 degrees 17 minutes and 20 seconds, you get 143 17 23.5. You do the same thing for the circle right. You're gonna say 216 42 33 plus 0 0 0 3.5. It's gonna be 216 42 36.5. Now when you add these two, they should give you exactly 360. Let's check. So this plus 143 17 23.5. You see, now it's 360 degrees exactly. So now we have to get our reduced bearing. In order for us to get our reduced bearing, is our reduced angle at circle left plus our joint bearing. So this one, you see, this was not supposed to be 143 17 20. It's supposed to be 23.5. So this is what I'm talking about. We have our joint bearing, which is 308, right? So you're gonna say that 308 plus 143, so that you get, never mind the structure of my drawing, right? Because according to our calculations, we're supposed to have our L at our fourth quadrant. Here I was just trying to make you guys understand what we're really talking about. In other words, it was supposed to be like this. Remember, this is our quadrant. We have our M here. So if our bearing from M to L is 308, which means our L is supposed to be here, and then our 143 supposed to be somewhere here. So we're gonna say 308 for 22.24 plus this 143, not this, the one from circle right, the one at circle left. This is our angle. This angle is too big, so we're gonna use this one, plus 143 17 23.5. So it's above 360. Remember, always when you have an angle that's greater than 360, you always subtract 360. So we're getting 91, which is on the second quadrant, just like I assumed. It's here, which means that our 143 is somewhere here. So when you move like this, it's going to be that bearing plus that one to get our L, which is here. So it's going to be 91 degrees 21:45.74 seconds. And then after that, we're going to our second part, our third part actually, not our second part. On our third part, we're given our instrument height. Usually when we do practicals, before you do anything, you have to measure your height of your instrument, which is your height of your tripod to your, remember it's going to be your tripod, and on top of your tripod, there's going to be your theodolite. A theodolite actually has a cross on its side. So you measure the distance from your peg to your cross, that's your instrument height. And then we have our target height. After that, we have to calculate also the reduced vertical angles. This is our vertical angle. So we have 87, 52, 47, 2222. So you're gonna say you do the same thing. You're gonna add these two. You add 87.52472222 plus 272.4772222. You see, they're not close to 1, they exceed 360, so we have to actually make these two their summation to add up to 360. So you're gonna say this one, which is 3607, you say 360 minus this one, minus, so it's gonna be 360 minus, so it's gonna be negative 0 degrees 0 minutes 7 seconds. So you divide it by 2, you get negative 3.5. So what you're going to do, you're gonna say this plus this, and then you write it here, the same thing, just like we did here when we're getting our reduced angle, but now we're getting our reduced vertical angle. So it's gonna be 87.52472222 minus 3.5. The reason I'm saying minus, because it's already negative. If we say plus negative, it's gonna just take time. So since it's negative, so automatically we're gonna subtract it. So it's gonna be so here it's now 87, 31, 25.5. We do the same thing for our circle, right? 272, 4772222 minus 0.003.5. So it's gonna be 2. It's gonna be 2, 7, 2, 28, 34.5. So when you add these two, they should give you 360 exactly. So we're just gonna add them and see. 31, 25.5. You see, it's 360 on the dot. So after that, we have to get our theta. Remember from tachometry, we used to have a theta where it's a slope angle. So we always say 90 degrees minus your reduced vertical angle at circle right. So it's gonna, for this one, it's gonna be 90 degrees minus 87, 31, 25.5, which is gonna give you your slope angle. When you're talking about the slope angle, we're actually referring to, remember this is going to be your triangle. This is your SD, this is your VD, this is your HD. This one is actually your slope angle, which is alpha. So we are going to say 90 degrees minus 87, which is your reduced vertical angle at circle left. So it's going to be 90 degrees minus 87, 31, 25.5. So your slope angle, it's 2 degrees, 28 minutes, 34.5 seconds. Okay, now we have to determine our HD. We have our SD as 198, that one is given. We have our slope angle as 2 degrees, 28 minutes, and 34.5 seconds. Okay, remember from your trig ratios, we have to determine your VD and HD. From this diagram, you can tell if we want to get VD, the relationship between SD, VD, and our alpha is that sine alpha equals VD, which is our opposite, divided by SD, which is our hypotenuse. So it's gonna be your VD, it's SD sine alpha. The same thing as our horizontal distance, which is our HD. The relationship between this, it's gonna be your cos alpha, it's always your HD, which is your adjacent, divided by your hypotenuse, which is your SD. So HD is SD cos alpha, which is our slope angle. So we're gonna say, okay, for our VD, we're just gonna substitute our HD, our SD, and our alpha. So for we're gonna start with our VD. It's gonna be 198 multiplied by 198. It's here. It's always given. So it's gonna be 198 multiplied by sine our slope angle, which is our alpha, 2 degrees 28 34.5. So our vertical distance, it's 8.55464196 meters. And then our HD, we do the same thing. Remember, we got this formula from this triangle. So you're gonna say your SD multiplied by cos of our slope angle. So it's gonna be 198 multiplied by cos of 228 34.5. So your HD, it's 197.815109 meters. Okay, after getting that, remember, now we have to get our coordinates of N. We have everything that we need. We have the reduced bearing. Remember, the joint bearing that we're going to use now is the one that's reduced bearing at our first table. So you're going to say, you have to calculate your change in Y and your change in X. We all know your change in Y is always HD, sine of reduced bearing. Change in X, HD, cos of reduced bearing. So our HD multiplied by sine of 91, not this one, but 91, 21, 45.74. That's your change in Y. It's gonna be 197.759165.1. And then our change in X is HD, which is 197.81511109 multiplied by the cos of 91, 21, 45.74. The change in X is negative 4.70433163. Okay, remember our station was at M. Always, in order for us to get our coordinates of N, we have to use the coordinates of M. So coordinates of M, we have no problem. We're given it was 89,26087. For X is 289043. 2.12. There's a 2 here. So it's gonna be, we have our change in Y and change in X. So our Y coordinates of our unknown point, it's gonna be 89,260.87, which is our Y coordinates of M, plus our change in Y, which is 197.7591651. So this is our coordinates, our Y coordinate of our unknown point 629. So we do the same thing for our X. It's gonna be 289043 2.12 plus, so it's negative 4 point something, so it's going to be minus 4.7043 4.7043 1. Okay, it's gonna be 2890432.12 plus minus 4.704331643. This is our new coordinates, the coordinates of our known point, which is 2890427.416. So this is the coordinates of n. Remember, we're given the elevations. We also have to determine the elevation of our unknown point, which is n. So remember, changing elevation. It's always the VD minus the target height plus the instrument height. This is our change in elevation formula from tachymetry table. So we have VD, we calculated VD here, which is 8.554641967. So it's gonna be 8.554641967 minus the target height, which is 1.455, it was given, minus plus the instrument height, which is 1.548, it was also given. So our change in elevation is 8.64764197. Okay, our new elevation, we're just gonna say the change in elevation plus our input elevation, which was given here with the coordinates. So it's gonna be this plus 1566.2, which means our new elevation is 1574.848. And that's it, guys. Thank you.